model, if I'm
Yes.
not wrong, in week 1 or week 2.
Yes, sir.
Okay. Yeah. Okay. So in this session, we will not be having any coding. So if you have some doubts about some concepts that you can ask, and we can discuss that.
Concept-wise, I guess it's all clear to me because I have literally gone through again the slides of the LLMs because I got some doubt, but that's clear now. So
Okay.
not for now. But yeah,
Okay. That.
in the part of week 4 of this DLP, so I guess we're not having for week 4 session, so I'm not going to ask for that, I guess.
Yeah. Okay.
It's about
Okay.
content, yeah.
Hi, Prashta. Good evening. Okay, so week 4 doubts we'll discuss during the week 4 session so that all other
Yes, sir.
students can also do. Yeah, okay, okay. Arushi, nice to know that. So Arushi, the thing is like that you should be, your concepts about the input should be very, very clear, how the input is given. So input is given in the form of the embeddings, and then we have got positional embeddings. We use the tokenizer for that. And thereafter, in the decoder, we have got attention mechanism in 2 phases. So one is the mask attention. So we do the mask attention, then we have got the uh, attention. Okay, why we are doing the mask attention? Because it is a generative model. So I don't want to have access to the future tokens to generate the next token. So I'm giving only attention to the previous tokens and the present token. And thereafter I have got then I pass through the layers and keep on doing the layer norm, and then in the output to, I get the distribution over all the tokens to generate that token. And then there is a loss function, and in the decoder model we take the entire loss over all the distributions, and by doing the back propagation of that loss, we keep on updating our weights. So that's how a decoder model works at a higher level.
Sir, if I could like ask in that only,
Yeah.
the question about masking comes from how we are like modeling our language, right? So it's because of we are doing causal language modeling. That's why
Yeah.
we are doing that masking, right, for the generation of the next word. So
Yes. Yes.
if we do for like let's say fill in the blanks type, it's I guess yeah. So fill in the blanks. So we will give only one mask token, and everything will be shown to the model. Uh, right, sir? So that depends on the modeling part. So if we do different type of modeling, based on that, our masking can be altered according to that, right, sir?
No, Rupanjan. So
Okay.
see, we have got the encoder model and we have got the decoder model.
Right.
Encoder model, what it does the bidirectional thing. So we don't require a mask. It gives the attention to all the tokens because it is trying to find out the masked word which you have masked. Okay.
Mm-hmm. Yes, sir.
In the decoder model, it is a generative model. For example, I have given I have given that I am going to Delhi.
Right.
So first token is go. After go, I'm training it. For example, my next token should be I.
Right.
Okay. Or for
Mhm.
example, Delhi is the capital of India. So when I'm giving Delhi, go, after go, Delhi should come. So I have fed the entire sentence, but for generation, it will not pay any attention to the future. It will pay attention to only go.
Yeah. Yeah,
Okay.
that's why the teacher forcing concept comes in because you have to give
Yes,
the
yes,
yeah. But
yes. So
okay.
yeah.
Yeah, continue.
Yeah, so this masked attention is the feature of your decoder models, and decoder models are the causal models. Okay, CLMs, causal language
Right.
models.
Causal language model.
Yes.
Okay, but actually one more thing is there, like when we uh, pass the embeddings like text which are masked, so we will give all the sentence. Of course, we are masking it so that will not
No.
affect the gradient of in the decoder model, right? So like when we
Yes.
give the
So
input to yeah.
Yeah, so Rupunjay, when is the masking happening? Remember that we are giving the full sentence. For example, Delhi is the capital of India. Okay.
Mhm. Yes.
Now, masking is happening after your query, key, and value when we are connecting. So there we have got a matrix where the right side corner, which is there, we are giving those infinity values
Yes, yes.
so that it becomes zero. Okay. So masking is happening there. So masking does not have to do anything with your embeddings, anything. We are giving everything, but we are masking. So effectively, what we are doing, we are not paying attention to the future tokens.
Okay, so from the starting, when we are giving embedding, let's say we have encoder decoder model, and the decoder part, we are giving the input fully,
Yes.
and then after doing, like, let's say, one layer of masked multi addition, it will mask the input, sorry, output of that first layer.
Not about the layer, it is about the token. Okay. For example, if you've got a just
Yeah, actually,
uh,
sorry, token, yeah, token embeddings, right?
okay, just give me a minute. I will just open and will present my screen.
It's actually open to me, so
Okay, just give me a minute.
okay.
Okay, just give me a minute. It is not happening. Mhm. Yeah, is this visible to all of you?
Yes, sir. Yes, sir.
Okay, I will try to crack my. Okay, so I will just use my mouse. So this is your encoder. This is your decoder. Okay. And generally, where do we use encoder decoder model? For example, translation tasks. So we have
Yes,
given here, for
translation.
example, English, and we are trying to translate to for some other language. So here, whatever you have given the entire sentence, it finds the context or the relation between them, and here is your output.
Right.
Okay.
Yes, sir.
Now, here in the decoder model, I have got Go. Okay.
Okay.
And now I'm giving, for example, during the training time, I'm giving, I know that, for example, I wrote Delhi is capital of India. Okay. And
Yes.
here it should come out कि भारत की राजधानी दिल्ली है.
Yes, sir.
Okay. So I know कि मेरा जो translation है, here my first word should be Bharat.
Yes.
Okay.
Yes, sir.
Okay. Bharat. And I can have full that भारत की राजधानी दिल्ली है, for example. यहाँ पर ये भारत आ गया. So मेरा जब I give go, so here I don't have anything. So first is my mask attention. So I can give my entire sentence here that भारत की राजधानी दिल्ली है here.
Okay.
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 भारत की राजधानी दिल्ली है यहाँ पर.
Okay.
Now what it will do? Now it should not pay any attention to this entire sentence for the first token. It should generate Bharat.
Yes.
Okay.
Yes.
So that's why where the mass attention happens. So, but I'm giving the embeddings of everything. Bharat
Yes,
ki
sir.
Rajdhani Delhi hai full.
Yes, sir.
So when I have got that matrix, which is looks like this, which is the here is the one, and rest it is like minus infinity. So effectively in the first step, it is paying attention to only this token. Go.
Okay.
Okay. It leaves everything. Now, when it comes to the next, it is 1 here, for example. It will
Yes.
give now to Bharat. Okay.
Yes, sir. So that's
Ah,
what I said, I guess. Ki the the negative infinity we did here, it
Yeah.
it added at the initial phase, like before inserting into the first embedding, sorry, that layer, mask attention head layer, right?
Yes, yes. So mask attention, I will share some resources with you in the G space. Okay. You can go through that paper and it will make things much, much more clear to you. Okay.
Yes, sir. So maybe I have a PDF opened here, like the exact page where it is shown in the LLM PDF. Maybe I can share.
Yes, yes, you can share. Yeah.
Sure. My screen visible, right?
Yes, yes, it is visible.
So I guess, yeah, this is the part where mass self-attention it comes. And yeah, so as I am confused here, so we are giving, let's say, 3 words. So for the first round, it's only going go, right? For
No,
the
no, it is, see, that is a concept. Again, I will share my screen with you.
means this right matrix, right? But this
Yes,
matrix happens before going to this layer, right?
no, no. So this
After,
matrix which is happening,
yes, sir.
you have calculated, and this matrix you are doing after K, and when you're calculating those Q and K.
Yes, sir. This one.
Okay. Yes. So you are not masking the embedding.
Okay.
Okay. You are not masking the embedding after this masking is happening during the attention process.
After giving output from this layer,
Not from this layer, within this layer.
within this
This,
layer. Okay, so
yes.
means after entering the words embeddings here, first of all, this matrix will be applied, right?
See, the first layer which is there, it is your
Yes, sir.
this
Yeah, masked multi-head self-attention. Yes,
multi-head attention. So
self-attention.
here, self-attention, which is there. So your embedding you are giving with the positional
Yes,
encoding,
yes, sir.
and thereafter you are calculating those Q, K, and V.
Yes,
But when you do Q dot K,
yes, sir.
because
I
you find
guess.
the exponential E that which comes, so that is the time where you add this. Okay, this mask attention which is there, this matrix which is there.
Okay.
Okay, so what happens effectively that those minus infinity values they come,
Mhm.
and then you calculate the value of that exponential of that full.
Okay.
Okay,
Okay.
Zadeke, which we call.
So this
So
this is you are saying, right? So the mask is
yes,
happening after the scaling.
yes, yes. Okay. So
Okay.
effectively, mathematically, we are doing masking by
Mhm.
choosing those minus infinity values.
Yes, yes, minus infinity, adding that to. But
Yes.
but sir, isn't this is like inefficient? Like we are doing all of the calculation in this
No, no, no. It is
matrix
efficient.
multiplication.
It is efficient. Okay.
Okay.
Okay. Yes.
Okay, it's
Okay.
clear to me. Yeah, sure.
Yes. Second important thing is for all of you to remember is that is an encoder model. So it is like your first prompt which is there. It is go, and it should come Bharat. Okay. For example, now I'm saying about inference. In the second, your second input will be what? Go plus Bharat. Okay, then it will generate the second token. Now it will come Bharat ki Rajdhani. Okay, so for Rajdhani, now your input will become Go Bharat ki, and Rajdhani should come. So that is for the inference. So at every step, your input size, your input which is there, it is getting concatenated. Okay.
So sir, basically the matrix which I showed, like diagonal matrix with infinity there. So every row is uh, about time steps. So first time step is first row. Then second, when it goes above and creates like Bharat. Then after it adds on to that, and second row is the second input, second time, right?
Yes.
So that
So your training, when you are doing the training,
yes, sir.
you can give the entire sentence, okay? And by the masking, it is not giving attention to the future words, and you take the full loss with all the distribution, and that happens during training. But in inference, you are giving one token at a time. So at T1 or T0, your first token is go. At T1 is the output of your first token. Okay, Go, whatever you got output from Go, that becomes your input. So every time step now they are getting concatenated. Is that okay?
Yes, sir. Yes, sir. It's clear.
Okay. Okay. If that is clear,
Yes, sir.
if there is some confusion in anybody's mind, please go through that LLM notes and everything will become clear. Okay.
So just
And
one more question I have. The modeling part, which is language modeling and like causal modeling, this is not like fixed, right? So that they used when they created the model like GPT-2 and all. If let's say I want to uh, train our model in some type of some type of question or some type of modeling, so I can create my own, right? The modeling,
yes, you can do that.
and for that I have to make changes to the transformers if I am using pre-trained, right? Otherwise I can.
Yes. So yes, you can do that.
Actually, I tried to do that for this Amazon ML course, but failed it because I'm getting
Okay.
lots of error.
Okay. So in DLP, you will get a lot of opportunities for doing so. I will encourage all of you to please explore the Hugging Face. Okay. Take the models, train them for, the various tasks which are there. So GPT is very, very good in generative model. Okay. For generating, you give it a text and it will generate. It will give you answers. BERT is good for classification, sentiment classification, because it takes the attention, it gives attention from both the sides. That's why, like for example, BERT, bidirectional. Okay. And now during your this NPP is coming, so it will be based on NLP, and you will be training one of the model for that task. Am I audible? Yes, Ripunjay. Hi,
Yeah,
Ritvik. Good
just
evening.
keep
Hi.
giving thumbs up.
Yeah, thank you. Hi, Anand. Good evening. Thanks, Arushi.
Yes. Good evening, sir.
Hi. Hi, Preshta. Good evening.
Good evening, sir.
Good evening, sir.
Hi. Hi, Preshta. How are you?
All good, sir. How are you?
I'm good. I'm good. Thanks. Okay. Anything else to discuss?
Yes, sir. That's the thing about that questions in the graded assignment, because I guess a lot of questions is like we are getting other answers for the GA3 too. Like I got the lots of people got this other answers and photos was
Okay.
there.
Okay. So no problem. See, there might be some confusion about the language. So, but I will encourage you to think that when you are attempting any graded assignment, then you should apply your knowledge of only that week or up to that week. Okay, please try to get what is asked. In fact, we will amend that question. However, for the present term, I'll not be able to help you. Okay, that 1 marks will not mean anything. It will be just 0.005%. Okay.
Yeah, so
But
that is no worries. But in
yeah.
this week 3 also that's happening. That's what I'm.
What is the week 3 question?
I
You
guess
have got
in
some-
week 3 also I didn't get. Okay, just let me show you. Just give me a minute.
Yes. So week 3 GS deadline is over, no?
Yes, sir.
Yeah, the deadline was yesterday.
Yeah. Okay. Then we can discuss. What was the exact doubt, Ripunjay?
So it was the question 6 of week 3, which is like we have to tell the ID of token ID of certain unmasked token. Question 6 of week 3.
So this is simple. This question which is there, it is based on your simple coding.
Yes, sir.
Okay, so it is how you are implementing that. So I will not be sharing the Colab, but I have checked all the answers and all the answers are correct. Because why I'm not sharing the Colab? Because then that Colab file gets distributed in
Yeah.
the, in that
Yes, sir,
makes
yes,
no
sir.
sense. Okay, but I can say with confidence, I myself I have checked all the answers and we are getting the correct answers. Okay. What you can do, Ripunjay, you can send me your collab. I will check that. Okay. In case
Okay,
there is
sir.
a discrepancy, that
Let-
you can send it to me and I will tell you where you are.
Okay, okay. I will maybe try once more all the questions. Then if I get wrong again, then I will just
Yes.
share with you.
Yeah, you can mail it to me and
Okay,
I will check
Sure,
that.
sir. Thank you, sir.
Okay, and like I have been mentioning earlier also, see, this is a course about DLP practice. So it is about more hands-on.
Yes, sir.
Okay, and all the assignments are also given in that way that you download the models, you download the tokenizers, you check that, how the tokenizing is happening, what are the different, spatial tokens. So every model which is there, it has got its own spatial tokens. Okay, so you'll find BERT is having its own different spatial tokens. GPT is having its own spatial tokens. So please build on that knowledge. Okay. So keep on doing, hands-on. These assignments which are there, they are just the beginning, just to, to make you enter that world. But you keep on exploring, and it's a very hands-on, very industry-ready course. The knowledge which you will gain, it will help you, everywhere. Okay. Any other thing from anybody? Okay. So if there is no further question, can we call it off? Can somebody give me a thumbs up?
Yes, sir. Well, from my side, it's
Yeah. Okay. Okay. Thanks for joining and happy learning. Wish you all the very best. Let's catch up on Friday for week 4 session. Thank you. Have a nice day. Bye bye.
Thank you, sir.
Thank you, sir.